All right, so let's look at the next examples. We have here the first one, log base 5 of x plus log base 5 of 4x minus 1 is equal to 1. All right, so now this one is a little bit more advanced in that we're going to have to use some previous properties. Because if our goal is to make this left side one logarithm, I don't want two separate ones, we're going to have to go back to our properties of logs. So since this is addition, okay, then what rule are we going to use to make this one? We're going to condense this log. We're going to use the product rule, where we have log base 5 of x times 4x minus 1, because remember product rule, when you add you're going to multiply, equals to 1. Now if you want to, we can go ahead and distribute that x to the 4x and 1. We have log base 5 of 4x squared minus x equals to 1. Now that we've condensed the left side, now let's at this point write this log, this equation, in exponential form. So we have here, what is the base? Let me put exp form. That's what we're going to do next. What's the base? 5 raised to what? The first power equals to 4x squared minus x. And then we know 5 to the first power is 5. We want to set this equation equal to 0. So we're going to subtract 5 to both sides. I'm not going to show that. You can write that in your notes, but we're going to subtract 5. So we have 0 is equal to 4x squared minus x minus 5. And then we have a trinomial. You can factor this, or you can use the quadratic formula. Okay, so let's solve. Well, the factors of, we have 4 times negative 5. That would be negative 20. That would give us 1. So here we have 4x, and then this is x. And then that would be the first term. Here we have 5, and then that would be 1. That's negative, and this is positive. So when we check first term, that's 4x squared. Outside term, that's positive 4x. Inside term, that's negative 5x. So that would give us a negative 1x, and we have minus 5. Now, set each of these factors equal to 0 and solve. Okay, we have x is equal to positive 5/4, and then we have x is equal to negative 1. All right, so we need to check our work. Okay, now if we go back, let's start with negative 1. When I plug negative 1 into this formula for x, back into the equation, we have log base 5 of negative 1. Well, this component, remember, this component, we don't want it to outright be negative. So since that's going to be a negative 1, and even if we try to put this into our calculator, let's see if I can find the, and it depends on the calculator. Okay, I want you to see this. If you click on math, go all the way down to the bottom, and I want to say these are with the TI-84s, not the 83s. But you have this feature where it says log base, where you can actually enter a different base. So I'm going to press enter here. So for my base here is 5, and then I'm going to put in negative 1. I want you to see what happens. Now I'm going to press enter. Well, let me move it, close it up here. Press enter. It says not real answer. There's an error. Either we can go back to it or we can quit. But if I go back to it, this component, what I'm circling here, if you follow the cursor, cannot be negative. So with me saying that, we're going to reject -1 as a solution. Therefore, if we plug in 5/4, it's positive 5/4, and because it's positive and it doesn't give us a 0, that will be our solution. Okay, let's look at the next example. Log base 3 of x plus 2 minus log base 3 of x minus 4 equals to 3. Here's a minus sign. We want one log on by itself on the right hand side or left hand side, but we want one log. So since this is a minus sign, we're going to use the quotient rule. We're going to write it as log base 3 of x plus 22 all over x minus 4 equals to 3. And once we write it as one log, then we're going to write this, what I'm pointing to, log base 3 of x plus 22 over x minus 4 equals to 3. We're going to write it in exponential form, starting with the base. So we're saying 3 cubed is equal to x plus 22 over x minus 4. That's what we're doing. And then let's solve it. We have 3 cubed, which is 27, equals to x plus 22 over x minus 4. Now, to get rid of this x minus 4, we have to multiply x minus 4 on both sides. I'm not going to show that. Understand, I want to get rid of this denominator, so multiply x minus 4 on both sides. So what you're going to have here is 27 times x minus 4 is equal to x plus 22. And we solve for x. So let's distribute the 27. So have you write that down. And we have 27 times x, that's 27x. We have 27 times 4. We have minus 108 equals to x plus 22. Bring your x over. That's going to give us 26x. And then we're going to add 108 to 22. That gives us 130. And then we're going to divide 26 to both sides. And we have x is equal to 5. Go back and plug 5 into this, making sure that it does not give us a negative or 0 solution for this part here. Here we have 5 plus 22, that's positive 27, so we're okay with the 5 here. And then when we plug 5 in to this particular term, 5 minus 4, that gives us positive 1, so we're okay. So our solution here is positive 5. All right, our last example. Okay, log base 2 of x minus 10 plus log base 2 of x minus 3 minus log base 2 of x is equal to 2. That left hand side, I want one logarithm. One. So remember in 4.3 we talked about how to use those product rules and the quotient rule. So we know the first two, we're going to use the product rule. So you're saying log base 2 of x minus 10 times x minus 3. Then we have minus log base 2 of x is equal to 2. And because we have subtraction, the minus sign, we're going to write this as a quotient. Log base 2 of x minus 10 times x minus 3 all over x is equal to 2. So before we go into writing this as an exponent, look at this numerator. X minus 10 times x minus 3, FOIL that, FOIL, x squared minus 3x minus 10x plus 30. We have here x squared minus 13x plus 30. So that's what this is equal to, the numerator, FOIL. So now that we have that FOILed, we're going to take, at this point, what we have, our last step, write it in exponent form. I'm going to write this in pink here. So what is the base? It's 2. Raised to what power? The second power is equal to x squared minus 13x plus 30 all over x. So we have 4 is equal to x squared minus 13x plus 30 all over x. Now, to get rid of this x that's in the denominator, multiply x on both sides. I'm not going to show that part. We've done enough of that in class. Take the x, multiply it on both sides, and this is what it looks like. You're going to have 4x is equal to x squared minus 13x plus 30. And then set this equation equal to 0. So we're going to subtract 4x to both sides. We have 0 is equal to x squared minus 17x plus 30. And then either you can use the quadratic formula or you can try to factor. And I would try to factor first. Well, the factors of 30, positive 30, that when you add those factors, it gives you negative 17. And that will be x minus 2, x minus 15. Set each of those factors equal to 0 and solve. So we have x is equal to 2, x is equal to 15. Okay, this is where we need to check our work. Check our solution here. Now, when we go back and plug 2 back into the original equation, look at this. We have 2 minus 10. What does that yield? What will be the answer? That will be negative 8. We don't want a negative number here. Let's look at the second term. We have 2 minus 3. That would give us negative 1. I showed you what happened on the calculator. That is going to be an error. Okay, so 2 is going to be the extraneous solution. Okay, but let's plug 15 in. We have 15 minus 10, that would give us 5. That's what we want, positive 5. And then we have here log base 2 of x minus 3. We say 5 minus 3. That gives us 15 minus 3. That would give us a 12. Positive 12, that's what we want. And here we have positive 15. Therefore, our solution, our only solution, is 15.